All right, last we will be converting grams to grams. So H2 plus O2 produces H2O. We have to balance that equation. The question is, how many grams of hydrogen gas are needed to react completely with 54 grams of oxygen? So first thing we need to do is balance the equation. So let's do that. HO on the other side. The left side has two H's. The left side has two O's. The right side has two H's and has one O. So the left side has two H's. The right side, two O's. The right side has one. So we can take 2 divided by 1, and that's going to give us 2. So put a 2. Because it's with the O and this is all 1, you have to put the 2 in the front. So now you multiply that 2 times all of this. 2 times H2 is 4. So cross out the 2, make it a 4. 2 times O gives us 2. So cross out the 1, make it a 2. So now we have 4 H's on the right and 2 on the left. So 4 divided by 2 is 2. So we're going to put that in front of the H2. So 2 times H2 is 4. So we're going to cross that out and make it a 4. And now it's balanced. 4, 4, 2, 2. Now we can actually answer the question. How many grams of hydrogen gas are needed to react completely with 54 grams of oxygen? So this is what they give us, 54 grams of oxygen. So that's what we are writing first. 54 grams of oxygen, so O2. When we did moles to moles, it was 2 lines. When we did moles to grams and grams to moles, it was 3 lines. But when you do grams to grams, you're actually going to be using 4 lines. So over 1, 2, 3, 4, because you're going to actually have to turn it into moles first and back into grams. So the question is, how many grams of hydrogen gas are needed? So that's what we're trying to end up with, hydrogen gas. So that's this right here, H2. So grams of hydrogen gas, H2. So remember, whatever is up here goes down here. So grams of O2 will go down here. And remember what I said in the other equation. When you have grams of something, you also have moles of that same thing. So if I have grams of O2 right here, on top, I'm going to have moles of O2. Same over here. If I have grams of H2, I'm going to have moles of H2. So again, whatever goes on top goes on the bottom. So if I got moles of O2 right there, on the bottom over here, I'm going to have moles of O2. And if I have moles of H2 over here, up here, I'm going to have moles of H2. So now we're going to have to find the molar mass of everything. And remember, for every gram, for the grams, 1 mole is equal to that molar mass. So whenever you have grams, just know the mole of that is 1. So now we need the molar mass of O2. On the periodic table, the atomic mass for O is 15.999. So times 2, that is going to give us 31.998. So that's what will be right here, 31.998. We can use the calculator to clarify it. 31.998. So then over here for H2, the molar mass, so the atomic mass is 1.008 times 2 will be 2.016. So up here, you're gonna have 2.016. So let's clarify it again. 1.008 times 2 equals 2.016. So now the only thing left is to find the molar ratio. So find H2. What's in front of the H2? A 2. So we're going to put a 2 in the front. What's in front of the O2? Nothing. So we're going to pretend that's 1. So we're going to put a 1. And now we're just going to multiply straight across. So 54 times, because remember, all of this is going to cross out. And the only thing you're going to be left with is grams of H2. So 54 times 1 times 2 times 2.016 is 217.73 over 31.998. So divided by 31.998. And the answer you should get is 6.80 grams of H2. So that would be the answer for this one. How many grams of hydrogen gas, which is H2, are needed to react completely with 54 grams of oxygen? The answer is 6.80 hydrogen gas, H2. So let's move to the next one. It says, how many grams of chlorine can be liberated from the decomposition of 64 grams of AuCl3? So first thing we need to do, balance the equation. So Au, which is gold, Cl, so it's only 2 elements, AuCl. So for Au, it's 1 on the left side, 3 chlorines on the left side. On the right side, you have 1 Au. On the right side, you have 2 chlorines. So again, this 3 is not going to turn into this 2, and this 2 is not going to turn into a 3. So the best thing to do would be to multiply them together to get 6. So cross that out, put a 6, cross that out, put a 6. So now I know I'm going to need 6 chlorines on each side. So I have 2 chlorines. 6 divided by 2 is going to give me 3. 6 divided by 6 divided by 3 is going to give me 2. So now I multiply that 2 times all of this. 2 times Au is going to give me 2. So cross out the 1, make it a 2. 2 times Cl3 is going to give me 6. So I put the 6. 3 times Cl2 on the right side gives me 6. But now I have 2 Aus on the left and 1 on the right. So I'm going to need to multiply by 2. So I'm going to put a 2 in front of the Au. 2 times Au, 2. So now I have 2, 2, 6, 6. So everything balanced now. Now I can answer the question. How many grams of chlorine can be liberated from the decomposition of 64 grams of AuCl3? So that's what they give us. 64 grams AuCl3 over 1. Come on. I mean, my pen is starting to mess up. All right. So again, since we're going from grams to grams, it's going to be 4 lines. So time 2, 3, 4. How many grams of chlorine can be liberated? So that's what we're trying to figure out. Grams of chlorine. So that'll be Cl2. So again, if I have grams of chlorine, I'm also going to have moles of chlorine on the bottom. Remember, again, whatever's up here goes down here. So grams of AuCl3. Again, if I have grams of something, I'm going to have moles of the same thing. So moles of AuCl3. So again, whatever's down up there goes down here. So right here, I'm going to have moles of AuCl3. And right here, I'm going to have moles of Cl2, because this is the molar ratio. When you're doing grams to grams, the third line is the molar ratio line. So I'm gonna have to find the molar mass for Cl2. So the atomic number for chlorine is 35.453 times 2. 35.453 times 2 is 70.906. Remember, the mole is 1. Whenever you got grams, the mole is 1. So now we need the atomic mass, the molar mass for AuCl3. So for gold, the atomic mass for gold is 107.87. And then chlorine is 35.453 times 3. So 35.453 times 3 is 106. So 106.36 plus the gold, which is 107.87. 214.23. And now you do the molar mass. So you look for the Cl2. What's in front of the Cl2? 3. What's in front of the AuCl3? 2. So that's the ratio, the molar ratio of 3 to 2. So now you just multiply everything out. 64, remember all of this is gonna cancel out. Only thing left is gonna be grams of Cl2. So 64 times 3 times 70.906 equals 13,613.95 over 214.23 times 2, which is 428.46. So now you finish dividing. 13,613.95 divided by 428.46. The answer to this problem is 31.77 grams of Cl2. So that's the answer to this. How many grams of chlorine can be liberated from the decomposition of 64 grams of AuCl3? 31.77 grams of Cl2. So those are the ways to do stoichiometry, converting from moles to moles, moles to grams, grams to moles, and finally grams to grams. I wish I would have knew this better when I was in high school and in college, but I didn't. Unfortunately, I had a good teacher, but I don't remember none of this stuff from high school and college. I had to learn it again. I feel like this is my first time ever learning this, like this year. But yeah, so that's how you do stoichiometry. So stay tuned. Thanks for tuning in. More videos coming soon. Trey T out. Peace. I just realized the camera cut some of it off. But yeah, so that's the work that was cut off by the camera. So you started out with 64 grams of AuCl3. So then you're gonna put grams of AuCl3 on the bottom of the second line and moles of AuCl3 on the top. Then for the third line, that's gonna be the molar ratio. So you're gonna put moles of AuCl3 on the bottom and moles of Cl2 on the top, and it's a 3-to-2 ratio. And the atomic mass, the molar mass for AuCl3 was 214.23. And on the last line, you're gonna have, because you're trying to find grams of chlorine, so that's gonna be on top, and moles of chlorine is gonna be at the bottom. So the atomic mass for chlorine Cl2 is 70.906. So then you just multiply everything out, and the answer you should get is 31.77 grams of Cl2.